Good evening, students. Good evening, good evening, good evening. Welcome to all the WC students. To all my wonderful students, how are you all doing? Yes. So, nothing to worry. We are almost coming to the end of receiving all the chapters. This is your Annie ma'am. Welcome back, welcome back. So, in a part of our board preparation, that is for 2024, students, till now I have sent you haloalkanes, haloarenes, aldehydes, ketones, amines chapter, coordination compounds, now electrochemistry. So we are left with DNF block, we are left with solutions, we are left with kinetics, everything rather. All the 10 chapters I'll be sending it very soon. So you quickly finish off because all of you holidays are going on. So study well, note it, and once it is done, we will do the final revision for the board exams. So today the chapter which I'm going to give you or just tell you what I think it is important, the most important. What is the weightage of the chapter? The weightage of the chapter is 9 marks for your board exam. Correct, students? So please concentrate, note everything. So in the first page, before I start, let me tell you, I have done one shot videos for all the chapters. Almost 1700 videos are there for grade 10, 11, 12 JEE and NEET students. So go back, watch one shot video of electrochemistry, come back to the notes. Let's start off the video. So in this particular first sheet, I have given the definition of Daniell cell, what are electrodes, electrolytes, what is salt bridge and everything. In that, I have given a detailed explanation of the particular electrode cell, the anodic half cell and cathodic half cell, and what is the overall reaction. Done. From there, gradually I am going and reaching into a concept called the 2 marks question. What is the role of salt bridge? And what are the characteristics of electrolyte in the salt bridge also I've given. So with this complete Daniell cell is covered. So from there, more explanation, I have further taken Daniell cell reactions of zinc and copper electrode with the cell notation, calculation of E naught cell and everything. Further, from there, after this, I have taken further examples here in this page with chromium and lead, more and more examples with nickel and silver. This is how I give notes, students. So it's an overall understanding. From there, gradually I have taken you into electrode potential and standard electrode potential. Here the definition is given to you all for separate, just adjacent to each other, electrode potential and standard electrode potential, so that when the examiner asks you, you should know the difference, the basic difference between both. After that, below, as you have mentioned in the box, what is the concentration, what is the pressure, how much should be the temperature, everything is given. Gradually, after electrode potential and standard electrode potential definitions, I have taken you into concept of very important, that is oxidation potential and reduction potential. This is what is important for your electrochemical cell, right? So the definition of oxidation potential, reduction potential, and how do you calculate E naught cell, I have given in the boxes. So that's a continuation. Now, after studying the concept of electrode potential, I have taken into a concept called factors affecting electrode potential. So what are the factors on which the electrode potential depends? So types we have learned. Now these are the factors. Now, gradually from there, after the factors, we need to study what is the concept of SRP and SOP. Standard electrode potential, standard oxidation potential, and standard reduction potential. Or oxidation, if it is SRP or OR, reduction potential or oxidation potential. Done. Now, from there, I have given both the standard directions. How do you write? And according to the IUPAC, what actually is your SRP? SRP is equal to minus of SOP. Again, I'm mentioning, please go back to your one-shot videos of electrochemistry where I have done completely line by line NCRT with the numericals and board papers. So this is your IUPAC notation for standard electrode potential. So that is nothing but the SRP. Done. So next, after that, I have taken you into the concept called what is cell electromotive force or cell voltage. Definition is given, representation also is given in this page. After your electrode potential, after your EMF, in that electrode potential, your SRPs and SOPs, I have come into a concept called EMF of the cell, where representation is given to you exactly. If you write, you'll get full marks. Yes, yeah, the electromotive concept I have taken in this way. And from there, I have gone into factors affecting electromotive cell or the EMF of the cell. So motive force of the cell, I have given what are the temperature conditions, pressure conditions, concentration, and what is the formula. Now, after we learn this definition and your concept, now important thing is you need to you need to solve the numericals. See, physical chemistry is nothing but application of concepts into numericals. So I have taken the concept, I have applied in the numericals which are there using this formula. That's done. So here solve it and see students, nothing. I just left it. So you can just solve it and do it. Further, one more numerical based on the standard cell potential. I have taken the example of zinc and mercury electrode. So they have given me, as I showed you, SRP is equal to minus of SOP. Based on that concept, I have solved this numerical. Once again mentioning, for the detailed videos, please watch one-shot videos. Every line of NCERT is covered in that. Done. Now further, I have taken one more numerical using zinc and lead electrodes. So again, how to calculate? Here I have mentioned SRP is equal to minus of SOP. So what values they have given? I have done the numericals. Done. Then I've gone to a concept of feasibility or spontaneity of cell reaction. So based on the Gibbs free energy, I have calculated how much amount of electrical work done. So this electrical work done, I have used the formula, I have applied it, and I have given a concept of feasibility of the reaction. How do you calculate? From there, gradually, I have substituted the values. I have derived the completely Gibbs free energy and standard Gibbs free energy also in this page. Gradually from there, proceeding standard hydrogen electrode, SHE, because your electrode cells, you need to know the different types of electrolytic cells. So now SHE, standard hydrogen electrode, which is taken as a standard, and to find out the potential of the unknown electrode, I have taken the concept as a reference electrode and explained here. So SHE complete step by step, what to write, how to study also have given. Then construction students, construction diagram. The diagram is also there in the NCERT figure 3.3. Now, how do you write your anodic half cell reaction? Cathodic half cell reaction is what I have given here for the SHE, because it's taken as a reference electrode. If you're taking the reference, if you're taking this, the electrode under study is cathode, then this becomes anode. If you're studying the other one as anode, this becomes a cathode. So both the cell reactions I have mentioned here. From there, cell representation. Just now I said, when SHE is taken as an anode, this is a cell reaction. When SHE is taken as a cathode, this is a cell reaction. So below I have mentioned what are the uses of SHE to determine the standard electrode potential also I have given. It's a 1-mark question. Done? Okay. Now from there, gradually, the use of SHE. So where we are using. So as I said, we are going to use it as a reference electrode. So here zinc we are taking as an anode. So on the other side, we are taking SHE, that is a standard, the reference electrode is a cathode. Done. From there, gradually we are going into equilibrium constant using Nernst equation. So Nernst equation, the maximum numericals would come from in electrochemistry. So gradually I have taken from the Daniell cell, I gradually took into Nernst equation. So Daniell cell basic reaction I have given here. From there, I have taken you into the Nernst cell equation. All right. Okay, so this is your Nernst representation, how you are applying the different values. I have given the Nernst equation the easy way. Now, gradually from there, I am going into the log value and finishing off the general reaction of the Nernst equation at equilibrium, what is going to happen. Now, below I have given certain numerical which is related to your Nernst equation. Done. From there, gradually, electrochemical cell and Gibbs free energy of the reaction, continuation of the Nernst equation, I have taken and calculated the final E cell notation or the E cell formula using standard electrode potential. Done. After that, from there, one example also I have taken here, Gibbs free energy, that is also done using the same Nernst equation. How we are going to derive the Nernst equation if it is given also I have done. So now I have taken the same concept and calculated, means under Gibbs free energy, one numerical I have done. This is how you're not going to substitute, where you're supposed to write the units, final value, how you're going to write, or use the values, everything I have mentioned in this. So believe me students, everything of NCERT is covered in this. From here, we are going to go to a concept called electrolytic cells. So electrochemical is done, now electrolytic cell. Definition and representation, I have shown it to you. So that either ways you can have a understanding of what is the difference between electrochemical and electrolytic. Once you study this, a concept of conductance is very important because conductance numericals maximum you get. So I think account the following type of questions you'll be getting from this. So here I have given the different types of conductors, metallic and electrolytic. So gradually from there, I have taken you into a concept, the differences rather. Here also I have given you, I've also given you, sorry, here I have given you the difference. Like if resistance is due to what kernels, resistance here, it's due to honey-water interaction. Means example with the solvent-solvent forces. So I've given you what happens when the temperature increases. Done. Now from there, I have taken you into a concept called conductance. So normally whenever I teach the students in the form of a difference, like resistance on this side, conductance on this side. So the formula is given, unit is given, see everything is mentioned here. Resistance and conductance is done. Similarly, after resistance and conductance, I have taught what is meant by specific resistance and resistivity, conductivity and specific conductance. Gradually with the definition and the units. Okay. Now conductance is over, resistance is over, conductivity is over, resistivity is over. Now what are we going to learn? Next important thing, the formulas and units. Very important because in the numericals you'll be using this. After everything is over, then I've gone into a concept called molar conductivity. Molar conductivity and equivalent conductivity. What is the representation and what is the definition? What is the formula and what are the units also have given in the next page. So comparative study is always easy. So see here, I have given the units, I have given the formula and how you're going to represent and get the final notation with the units, both molar conductivity and equivalent conductivity. So here I have given you, I think, factors affecting electrical conductance. So I have given you what factors affect the conductance, because the question they'll give you, if there is increase in temperature, what will happen to conductance? So how it is. So this is how you have to understand the concept. From there, I have taken what are the factors affecting ionic conductance in this page. Gradually, when I speak about ionic conductance, measurement of ionic conductivity using Wheatstone bridge. So this conductivity concept using Wheatstone bridge I have mentioned here. Okay. So numericals will not be much asked from the Wheatstone bridge, but account for the following questions will be asked. From there, gradually, again, Wheatstone bridge explanation I have given here. After I take you from the Wheatstone bridge, I'm not here. Basically, I have finished the concept of the Wheatstone bridge relating to your resistance. So how do you use that? How I can use a Wheatstone bridge in finding out the resistance? Yes, I've applied it in this formula, right? Then from there, see here, I have given a numerical, both the sides. Numerical, I think little zoom in I'll do so that it is easy. See here, I've given the numerical in comparison so that I can calculate the answers from this. From there, I have gone into a concept of conductance. So what happens to the weak electrolytes when you have strong electrolytes? What will happen? So this question is always asked dilution. They'll say 0.05 normal, molar, like that. They'll be giving you the concept. So the concept is here. You can apply this concept in your numerical. Yes. Then gradually, I have further gone into a concept of dilution. Okay, the dilution, weak electrolytes, strong electrolytes, how they are and everything. Done. From there, after that concept, I have gone into variation of conductivity with dilution concentration. I said just now said no, they'll give you certain concentration whether the dilution conductance increases or not. So I have given you as a concentration decreases, dilution increases. Obviously, when the dilution increases, conductance increases and conductivity decreases. What is the reason also I have mentioned here. Now from there, gradually we will go into a concept of molar conductivity in this page. And I have related this molar conductivity to a concept called, means this molar conductivity with the dilution factor. So they will ask you this concept, students, very important. So experimentally, when dilution is increasing, volume increases. Since molarity and non-molarity are inversely related to volume, so I have given you a concept here. What happens to the molarity, normality, molar conductivity, and equivalent conductivity also. So everything, the whole concept is covered in this sheet. Okay, write it carefully. And any doubts, please ask me in the comment section. From there, gradually we will go into a concept called variation of molar conductivity or equivalent conductivity. So for strong electrolytes, we have solved this equation using the graph. From there, for the strong electrolytes, we have shown what is the meaning of limiting molar conductivity, how we have gone in conductivity at infinite dilution. Also, the concept is mentioned here. So everything I've mentioned in points, students, I gradually have mentioned here. You can understand and note it. Then limiting molar conductivity, on-Sager equation, that also done. Okay. Then from there, so dy Huckel on-Sager equation, what are the terminology also I have given. From there, gradually go into a concept called variation of molar conductivity with concentration. So that strong electrolyte is done. Now it is weak electrolyte. Concept is easy. I've explained it. Please go through the video and you can write this answer. Same concept of weak electrolytes. That's also done for Kohlrausch. Gradually, Kohlrausch law of independent migration. Numericals are very important. I have given you a lot of numericals in this. So what is meant by Kohlrausch law? Definition, formula, and everything. Now, I've taken different examples for Kohlrausch law here. 2 examples. Gradually, 3 more examples, and I started solving certain numericals in this. I'll zoom in. I started solving certain numericals also in this, applying the Kohlrausch law. All right. Then from there, applications of Kohlrausch law applications, and then I came into a concept called Faraday's laws. Faraday's law sums. Then I have given the numericals related to your Faraday's law in this page. Zoom out. Okay, Faraday's law. From there, gradually some more sums for your Faraday's laws. Your first law numericals, I have to explain the concept and solve the numeric sums. And gradually from there, Faraday's second law also, where we take different electrodes. So that formula also is given along with the definition. Then gradually, taking the formula, I have picked up different concepts, different formulas, and added what actually is E1, what actually is E2. And numericals also have solved this page. All right. So this is done with the Faraday's laws, numericals. Now, last topic, that is product of electrolysis. Very important topic, students. So product of electrolysis, what it depends upon. It depends upon nature of electrodes, electrolyte, medium of electrode, concentration of electrolyte. What are the examples? Everything I have given. So I did a detailed study, case 1, what happens if you have molten electrolytes. Very important information. Molten electrolytes, what happens? From there, I've gone to case 2. What happens when you have a platinum electrode? Right? And here molten, this is aqueous electrolytes, that is molten electrolytes. What is the thing? Then I have taken case 3 where you have dilute electrolyte. This concept also I have given, both the anodic and cathodic reaction. Gradually from there, case 4 I have gone where we have taken aqueous NaCl concentrate with mercury as cathode. This is also done. After that, case 5 I have taken aqueous NaCl with silver electrode. This is one more concept. Both the anodic reaction, cathodic reaction is mentioned here. From there, after all the 5 cases, that's where all the 5 cases, I think the complete information will get covered in all the 5 cases. Then we come to batteries. Batteries. All right. So different batteries, commercial type batteries, in that primary and secondary. Differences are given here. Examples are also given. After this one, product of electrolysis, little continuation of that I have mentioned here. What are the factors which it depends upon? From there, okay, this is done, students. Product of electrolysis. Little continuation of the same thing, students. Same continuation. So I think while clicking, it took like this. Okay, molten electrolysis of molten NaCl. I've clicked the photo in this way. Sorry, I'll zoom in. This is for your NaCl. Okay, overall reaction. This is electrolysis aqueous NaCl. Further proceeding. Then I have continued. Now I have taken in this page concentrated NaCl. Concentrated NaCl, aqueous is done. From there, net reaction. Okay, now molten lead bromide I have taken. The concept is given earlier. Now the continuation of the concept. Then electrolysis of water is given here. Gradually, we have taken, I finished the concept of electrolysis of water in this way. Okay, so anodic compartment, cathodic compartment, what is the ratio? Aqueous copper sulfate also is taken here. Then, all right, so gradually overall reaction also I have completed. So the complete product of electrolysis continues, students, all these pages. From there, electrolysis of concentrated sulfuric acid, then dilute sulfuric acid is one more concept. Then this is done. Now this is a continuation of the batteries. So batteries I've written in the last. So batteries concept, why we're using batteries, what are the batteries. This is a repetition of the earlier page. Then primary cells, in primary cells what are the batteries done. In the primary cell, dry cell, these are the cell reactions. And mercury cell, the button cell, batteries, this is also done. Secondary cells, this is also done. Cell reactions, this is also done. Overall cell reaction, this is for your battery, your rechargeable battery using lead electrodes. From there, overall cell, I ended the chapter using fuel cells. In this fuel cells, what is the definition, what happens in fuel cell, where we are using the byproducts of water. Done, students. That's all. So here, basically, the complete chapter till here is done. Everything I have covered line by line. So I request all of you to please take a pen, a book, and start writing. I'll be uploading the remaining chapters also. After that, we will start the final revision for your books. Inform all your friends. I request you to please like the video as much as you can. It doesn't cost anything. Share this video to all your friends. Thank you so much for watching. I'll meet you again with the next chapter very soon. Bye bye. Thank you, students. Take care of yourself. Bye.